With implicit differentiation, we have to realize that whenever we are finding the derivative, it is with respect to x. And we're starting to say that because we need to keep in mind that not every function that we look at or every relation is just going to be y in terms of x. In other words, what about if we wanted to find the equation of a tangent line to a circle? So that's still possible. We still have some kind of circle, but what if I wanted the equation of the line tangent to that circle at some given x value? We still need to be able to write that line and find the slope and use it. So in other words, we've got to define a way to find the derivative of y, but still stay with respect to x. And in doing so, that's where we get these terms, dy dx. So that's what we're going to be using throughout here. If we do the derivative of y, it's going to be the derivative of y with respect to x. All right, so let's see if we can't find our derivative here. So we're going to go through, and the derivative of x squared is just like we normally would do. It's 2x minus, and we're still going to say the derivative of y squared is 2y, but we need to note that we took the derivative of y with respect to x equals, and the derivative of 16 is 0. And now let's solve our equation for dy dx. So I'm going to subtract 2x over. So I'm going to have negative 2y dy dx equals negative 2x. And then again, we're going to continue to solve for dy dx. So we're going to divide both sides by 2y. So dy dx equals a positive x over y. And now they want us to evaluate this at our point negative 5, 3. So to evaluate this, be careful with your notation. Dy dx evaluated at the point negative 5, 3 is going to be negative 5 over 3. All right, let's try example 2. And again, you do want to start off by going through all of our derivatives. And do note that we have a product rule here. We have x times y. So right here, you still incorporate the product rule. You still might have the quotient rule, and you still might have to do chain rule inside all of this. So let's go through the product rule. We have the first times this derivative of the second, and derivative of y is 1. And then we're going to have 1, but we need to take our note that it's dy dx, take the derivative of y with respect to x. So that's first times the derivative of the second plus the second times the derivative of the first plus derivative of y again is 1, but we note it with dy dx, and that's equal to 0. And again here, let's clean up all those 1's. So we really have x dy dx plus y plus dy dx equals 0. We do need to move y over to the other side, so we have x dy dx plus dy dx equals, and we're going to subtract y over, so that's going to be negative y. And then we're going to go ahead and factor out dy dx. And if I do that, that's going to be our GCF, so we're going to do parentheses. We have an x plus, and since we're dividing, that would be a 1, equals negative y. And then finally, solving for dy dx equals negative y over x plus 1. And again, they wanted us to evaluate this at the point 3, 2. So we need to note that, and do watch our notation. We're going to have dy dx evaluated at the point 3, 2. So we're going to plug in a 2 for y, so that's going to be negative 2 over 3 plus 1, and you can leave it just like that. All right, moving on to the next. All right, so again, same pattern. Now we're going to have some product rule going on right here. So let's go ahead and do our derivative of x is just going to be 1 plus, and I'm going to just let that 3 sit out there. It is just a coefficient, and it's just going to be brought down. And now let's do the derivative of the, or do the product rule here. So I have first times the derivative of the second, 1 dy dx, plus the second times the derivative of the first. All right, and then minus, and our derivative here is going to be 4y dy dx, and all of that equals 0. All right, so here we are going to distribute that 3 through, so I have 1 plus, this is going to be 3x dy dx plus 3y minus 4y dy dx equals 0. And we do need to isolate our dy dx and keep it on one side. So we're going to move everything else to the other. So we have 3x dy dx minus 4y dy dx equals, and we're going to move our 1 over and our positive 3y. Now we're going to take out a GCF of dy dx, and left over we have 3x minus 4y, and that equals negative 1 minus 3y, and then we're going to divide both sides by 3x minus 4y. And there's going to be our dy dx. Okay, number 4, more of the same. My gosh, what a problem. So let's see if we can't get through this. So we're going to have 3 y squared dy dx, and then we have plus 10y dy dx minus 5 dy dx minus 2x equals 0. Well, my gracious, all of those terms have dy dx in it, and then I'm going to move this 2 over. So I'm going to do a couple of steps all together. We have our dy dx, and inside I have 3y squared plus 10y minus 5 equals 2x. I went ahead and moved that over, and now I'm going to divide. So I have dy dx equals 2x over 3y squared plus 10y minus 5. All right, moving on. So more of the same, and this looks like we're going to have more implicit, but it's going to review our derivatives in natural log, which is great. So let's go ahead and find our product rule here, because we do have x times natural log y. So doing our derivative, we have the first times the derivative of the second. So the derivative of the natural log of y is going to be the derivative of y over y. So that's going to be 1 over y. And then we note this with dy dx. So there's first times the derivative of the second plus the second times derivative of the first, which is going to be 1, equals the derivative of e cubed. Now that's just going to be 0. There's no x's here whatsoever. That's a constant value. So let's see, we need to subtract our natural log of y over. So I have x, and I'm going to go ahead and multiply this x to 1 over y. So that's going to give me xy dy dx equals negative natural log y. And then I'm going to multiply by the reciprocal here. So dy dx equals the negative natural log of y times y over x. All right, so again, doing the same over here for number 6. So we need to go ahead and do our product rule. So we're going to do, and notice it says y prime. That's the same thing as dy dx, same exact thing. So let's go through our product rule. So we have first times the derivative of the second plus the second times the derivative of the first. So we're just going to put y prime. And that's the same thing as saying 1 dy dx. So we're going to have just that. And that's going to be equal to 0. And we're going to move our y, e to the x over. So we have e to the x y prime equals negative y e to the x. And then y prime equals negative y times e to the x over e to the x. And you can leave it just like that. All right, moving on. More of some great review here with our cosine. And again, notice that we have x times y. So when we do the derivative of the inside, we're going to have the product rule with it. So let's start off with the derivative of cosine is negative sine. So I'm going to have negative sine of xy. But then that's going to be times the derivative of xy. So that's going to be the product rule. So I'm going to have the first times the derivative of the second, which is 1y prime, plus the second times the derivative of the first, which is 1. So we've got that side equals, and derivative of x is 1 plus derivative of 3y is 3y prime. And again, keep in mind y prime is the same as 1 dy dx. All right, so looking at this, we have a y prime in here, so we're going to have to do some multiplication through. So I have negative, I'm going to do our distributive property, negative x y prime sine of xy minus y sine of xy. That equals 1 plus 3y prime. All right, so we need to move this over to the other side, and we need to move y prime back over here. So we have negative x y prime sine of xy, and I'm going to move our minus 3y prime, let's get those together on one side, equals 1 plus y sine of xy. A lot of algebra. Now let's factor out our GCF, and our GCF here, if we'll note, is going to be that y prime there and there. So let's factor that out. So I'm going to have y prime, and then times negative x sine xy, and then minus 3 equals all this other stuff over here. All right, and then we'll divide. So we have y prime equals 1 plus y sine of xy all over negative x sine xy minus 3. All right, the fun just continues. So here we're going to do the derivative of natural log. Remember that derivative, we talked about a couple of different forms, and we did talk about the natural log of stuff. If we did that derivative, that was going to be stuff prime, which means the derivative of stuff over the stuff. Stuff prime over stuff. So right here's the stuff, and so we need to talk about the derivative of that, and that's going to be the product rule. So let's go through that. So we're going to have the first times the derivative of the second plus the second times the derivative of the first, and all of that is back over just the stuff, which is xy. And equals, and the derivative of inverse tan, this is just a formula that you need to memorize. I know it's just wonderful. It's going to be 1 over 1 plus x squared. That's just memorize it. We can prove it, but there's no need to. So you're going to get 1 over 1 plus x squared. So let's clear up what we have. We have x y prime plus y all over xy equals 1 over 1 plus x squared. Now, we're trying to solve for, and it's so easy to get lost in the sauce here, you're trying to solve for that. So in that process, let's take this from the denominator and multiply it up here. So if we do that, we have xy prime plus y equals xy over 1 plus x squared. All right, and then we're going to, dear goodness, subtract y over. So we're going to have, the bottom of the page, we have xy prime equals xy over 1 plus x squared minus y. That's going to be this subtracted over. And then we've got to divide all that gobbledygook by x. Now this is where most kids finally catch on that you don't have to simplify this mess. So we're going to have all of this, right? And then it's all divided by x. And leave it just like that. It's okay that it's nasty. It's all right. Just leave it like it is. All right, more fun. Here we have the equation, find the equation of the line tangent. Now, part B says the line normal. We're not going to test that. So the normal just means perpendicular or the negative reciprocal. So, we got enough to do. All right, so the equation of the line tangent at negative 1, 2. So we know that equation of that tangent line, y minus y1 equals m times x minus x1. We are given x1 and y1, so we need slope, we need m, which means I need to take the derivative of all of that. So when I do, I have 2x minus, this is product rule, so I'm going to put that minus in brackets. We have the first times the derivative of the second, plus the second times the derivative of the first, plus, and then we have 2y, y prime. And all of that is equal to derivative of 7 is 0. All right, so now let's go through and we're going to have to distribute our negatives. So we have 2x. Well, you know what? No, let's back up. We need this derivative's value. So I wouldn't worry about all of the algebra. Let's go ahead and plug in. So we know x is negative 1 and y is 2. So 2 times negative 1, so that's going to give me negative 2 minus, x again is negative 1 times y prime, so negative y prime, plus 2, plus 2 times 2, so 4y prime equals 0. And we just solve for y prime. I think this is a little bit easier. So we're going to have negative 2, distribute your negatives, so plus y prime minus 2 plus 4y prime equals 0. And so let's put together our like terms. So negative 2 and negative 2, that's going to be negative 4. So I have negative 4 and then plus 5y prime equals 0. So solve for y prime, we're going to add 4 over. So 5y prime equals 4. So y prime is going to be 4/5. So we found our slope. So now we're ready to write the equation of our line. And that equation is going to be y minus 2 equals our slope times x minus a negative 1. All right, and again, we're going to skip B. Now the next one, we are going to do the second derivative, as if the first derivative was not fun enough. So let's go ahead and have at it. Second derivative just means we're going to do the derivative twice. We're going to go through this awesome process 2 times. So let's go ahead and do our derivative. That's going to be 2x plus 2y, y prime equals 0. All right, and so from here, we can move stuff over. So we have 2y, y prime equals negative 2x. And then solving for y prime, that's going to give me negative 2x over 2y. And that simplifies down to negative x over y. Now we're ready for the second derivative. So we're going to do y prime prime. And we have the quotient rule. So we're going to do the bottom times the derivative of the top minus the top times derivative of the bottom. All of that is over bottom squared. Now this is where we do have to be careful. Most of the time they want you to replace that y prime in the second derivative with what you found it to be up here. So your final answer, you do need to make that substitution, but 99% of the time they do ask that on the AP exam. So you have y double prime equals, that's going to be a negative y, it's going to be plus a positive. So I'm going to have plus x times negative x over y, making that substitution. And then this is all over y squared. And don't try to clean that up, just leave it like it is. All right, so more of the same over here. We're still finding that second derivative. So the derivative of cosine of y, we know is going to be negative sine y. But then we also have to say times the derivative of y, or y prime, derivative with respect to y, or with respect to x, sorry, and all of that equals 1. So to solve for y prime, that's going to give me 1 over negative sine y. Now we're ready to do our second derivative. So y prime prime equals the bottom times the derivative of the top minus the top times derivative of the bottom, which is going to give us negative cosine y, times y prime, and that is all over the bottom squared. So that's going to be, not that, I don't know what the heck that was, negative sine of y all squared. And again, we're not quite finished because we have a y prime, and most of the time we do have to go back and replace that. So this first term is going to go out to 0, and we've got minus a negative here, so plus cosine y times, well, y prime, which we found that to be negative 1 over sine y. And all of this is over negative sine y all squared.